Okay, we're going to do a little conversion from decimal into binary and hex, and we're going to do this manually without a converter, although obviously you've got lots of converters online. What I've done to start with is in the binary section here, I've put all my powers, so that's 2 to the power 0, 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 8 is 256. I've kept going down here. Over on the hex side, these are powers of 16, 16 to the power 0, 16 to the power 1, 16 squared, 16 cubed, 16 to the power 4. Okay, right, so we'll do the binary one first. So the number that I'm converting in both instances is 10,201. So I'm going to look down here and I'm going to find the biggest number that can go into that, which is 8192. So I'm going to use one of those. And I'm going to subtract that and see what it is that I've got left over. So I've got 9, 0, 0, and 2. So I've got 2009 left over. So I'm not going to use any of those, but I am going to have a 1024. Okay, so with my 2009, I looked for the biggest number that would go into it again. So 1024. All right. Now I'm going to do the subtractions quite quickly here. So that is 985. Okay, so I'm going to look for the next biggest number, which is 512. Do the subtraction again. 374. Next biggest number that goes into 473, 256. Next biggest number, 128. Next biggest number, 64. So I've got no 32, so I'm just going to go over now to here. 25, take away 16, leaves me 9, 8, and I've got 1 left over. So I can see here that my conversion to binary is 1 0 0 1 1 1 1 1 0 1 1 0 0 1 3 4 5 6 7 8 9 10 11 12 13 14 7 8 9 10 11 12 13 14. Okay, so a 14-digit binary number. Okay, now the hex one is going to take up less space, but it's going to be a little more challenging, because in this instance we were only ever subtracting 1 of something. But I'm going to start off in the same way, and I'm going to say what's the biggest of these powers that can go into here, and it's 4096. But more than one of them can go into there. Okay, so in fact 2 of them, which is 8192. So we're going to use 2 of these, 8192, and we're going to take that away. And what's not that surprising is that the numbers that we use here end up having appeared in here as well. Okay, 2009. So what am I going to take away from here? I'm going to take away some 256s. How many 256s? Well, 8 256s is bigger than that, so I suspect it's 7. Let's just quickly do the maths there. 256 times 7 is 42, 35, 39, 3, 17, 92. 92, and we're going to take that away, and we have oops daisy. Okay, so we have 217, and that's good. We can see that down here as well. So we are going to subtract some 16s. How many 16s go into 217? Well, this is where our hex gets quite interesting, because we can see that it's more than 10. So 10 is 160. 3 16s are 48. So 13 16s are 208. So so 13 in hex is 9 A, B, C, D. Okay, so we're going to use D 16s, and we have left over 9, and we use 9 ones. So our answer here is 2, 7, D, 9. Okay, so a little bit more complicated on the hex side. Obviously the answer is a lot shorter, 4 digits rather than 14, but we're having to work in multiples of 256 and then multiples of 16, including multiples of more than 10. Okay, so in this instance we use 13, and let's just remember 9, 10, 11, 12, 13. Okay, all right, good.